Scientists just discovered that every black hole in the universe might be a portal to another dimension, and the proof came from the most unlikely place, a laboratory buried beneath Switzerland. When CERN researchers created microscopic black holes that vanished in nanoseconds, they accidentally unlocked evidence that our entire reality could be nothing more than a hologram projected from the edge of spacetime itself. Here's the mind-bending part. These tiny gravitational monsters might be the key to understanding whether parallel universes actually exist. But did you know that Stephen Hawking predicted this discovery decades before we had the technology to prove it? The experiment setup. Scientists just fired particles at 99.9% the speed of light and accidentally opened a doorway to another dimension. At CERN's Large Hadron Collider, a 27-kilometer underground ring buried beneath the Swiss-French border, physicists achieved something that sounds straight out of science fiction. They accelerated protons to unimaginable speeds, creating collision energies so intense that they briefly tore holes in the fabric of space-time itself. This wasn't some random experiment gone wrong, this was deliberate, calculated madness. The LHC uses superconducting magnets cooled to minus 271 degrees Celsius, colder than outer space, to guide these particle beams around the massive ring. When these protons collide head-on, they recreate conditions that existed just moments after the Big Bang, generating temperatures 100,000 times hotter than the sun's core. The sheer power required for this experiment could supply electricity to an entire city, but scientists needed every bit of that energy to push the boundaries of known physics. What makes this even more incredible is that these collisions happen 40 million times per second, with each crash producing a shower of exotic particles that exist for mere nanoseconds before vanishing forever. The detectors surrounding the collision points are technological marvels themselves, capable of tracking particles moving at near light speed and measuring their properties with mind-boggling precision. This setup became the stage for humanity's most ambitious attempt to understand the fundamental nature of reality itself. Creating tiny black holes. What if I told you that right now, scientists are casually manufacturing objects so dense that light itself cannot escape them? At CERN, when protons smash into each other at nearly the speed of light, something extraordinary happens in that split second of collision. Microscopic black holes spontaneously pop into existence. These aren't the galaxy-devouring monsters you see in movies. We're talking about quantum-scale phenomena smaller than a single atom, existing in a realm where normal physics breaks down completely. The energy density at the collision point becomes so extreme that space-time literally curves in on itself, creating these tiny gravitational wells that would make Einstein's head spin. Here's the mind-bending part. These black holes are so small they make a proton look like a basketball in comparison, yet they contain enough concentrated mass energy to theoretically warp the fabric of reality around them. The collision energies required to create these microscopic monsters are absolutely staggering. We're talking about recreating conditions that existed in the first trillionth of a second after the Big Bang. When two protons collide at these incredible speeds, they don't just bounce off each other like billiard balls, they completely annihilate, converting their mass into pure energy according to Einstein's famous E=mc² equation. This energy then condenses back into matter in the most exotic forms possible, including these fleeting black holes that exist for time frames so brief that even light doesn't have time to travel the width of a proton before they vanish. Why tiny black holes? Stephen Hawking just proved that the smallest black holes are actually the most dangerous, but not in the way you think. These microscopic black holes created at CERN are completely safe precisely because they're so tiny, thanks to a mind-blowing phenomenon called Hawking radiation that turns everything we know about black holes upside down. Here's where it gets crazy. While massive black holes in space can live for trillions of years, these quantum-sized ones evaporate almost instantly because smaller black holes actually radiate energy faster than larger ones. It's like having a tiny campfire that burns 1,000 times hotter than a massive bonfire, consuming itself in a brilliant flash of energy. Hawking discovered that black holes aren't perfectly black at all. They're constantly leaking particles and energy back into the universe, slowly shrinking over time. The smaller the black hole, the faster this evaporation process happens, which means CERN's microscopic creations vanish in less than 10 to the minus 23rd seconds. That's faster than light can travel across a proton. This counterintuitive behavior occurs because of quantum mechanics at the event horizon, where virtual particle pairs are constantly being created and destroyed. When this happens near a black hole, one particle falls in while the other escapes, carrying away energy and causing the black hole to shrink. The temperature of this radiation is inversely proportional to the black hole's mass, so these tiny ones are incredibly hot, hotter than anything else in the known universe, which is exactly why they disappear so quickly, leaving behind only valuable data about the fundamental nature of spacetime itself. The purpose behind it. So scientists just discovered that our entire universe might actually be a hologram, and well, CERN's black hole experiments are the key to proving it. The real purpose behind creating these microscopic black holes wasn't just scientific curiosity. No, it was humanity's desperate attempt to understand whether we're living in a three-dimensional illusion projected from a two-dimensional surface. By studying how these tiny black holes behave, physicists are testing the fundamental nature of gravity itself, and honestly, whether Einstein's theories hold up in the most extreme conditions imaginable. The experiments are designed to probe extra dimensions that could be hiding right under our noses, folded up so small that we can't normally detect them. When particles collide at these incredible energies, they might briefly escape into these hidden dimensions, leaving behind telltale signatures that could, revolutionize our understanding of reality. Scientists are essentially using these black holes as cosmic X-ray machines, peering into the deepest layers of space-time to see if string theory is correct about there being up to 11 dimensions in total. The data from these collisions could reveal whether gravity is actually much stronger than we think, but just appears weak because it's leaking into these extra dimensions. And this isn't just academic curiosity. Understanding the true nature of gravity and dimensions could unlock technologies we can barely comprehend, from faster-than-light travel to manipulating space-time itself. Every collision brings us closer to answering the ultimate question: what is the true structure of the universe we inhabit? Public fears and myths. The world literally thought CERN was about to end humanity, and honestly, millions of people started panic buying survival supplies when the news broke. Social media exploded with doomsday theories as people genuinely believed that scientists were recklessly gambling with the entire planet's existence by creating artificial black holes that could grow uncontrollably and devour Earth from the inside out. Conspiracy theorists flooded the internet with terrifying scenarios where these microscopic monsters would merge together, creating an unstoppable gravitational apocalypse that would suck in everything from buildings to entire continents. The fear was so intense that CERN received thousands of angry emails and death threats from people convinced that physicists had lost their minds and were about to trigger the end of the world. News outlets sensationalized the story with headlines screaming about scientists playing God in the experiment that could kill us all, just feeding the global hysteria. Religious groups declared it was humanity's attempt to breach the gates of heaven, while others claimed it was opening portals to hell itself. The panic reached such heights that some people actually fled to remote locations, believing that distance might somehow protect them from a planet-consuming black hole. Scientists found themselves in the bizarre position of having to reassure the entire world that they weren't suicidal maniacs bent on universal destruction. The irony was that these same people used GPS systems and medical scanners daily, technologies that emerged from previous dangerous physics experiments that had also terrified the public decades earlier. What actually happened? The moment everyone feared would destroy civilization actually became the greatest scientific triumph in human history. When CERN's microscopic black holes materialized and vanished in those impossibly brief nanoseconds, they left behind a treasure trove of data that confirmed some of the most mind-bending theories about how our universe actually works. Instead of the apocalyptic scenario that had terrified millions, scientists witnessed exactly what Stephen Hawking and other brilliant physicists had predicted decades earlier. These quantum-scale gravitational monsters evaporated in brilliant flashes of Hawking radiation, proving that our understanding of quantum mechanics was spot on. The detectors surrounding the collision points captured every photon, every particle, every trace of energy released during these black hole deaths, creating a detailed map of how spacetime behaves under the most extreme conditions possible. What emerged from this data was revolutionary confirmation that information isn't actually destroyed when it falls into a black hole, solving one of physics' greatest paradoxes. The measurements showed that these tiny black holes followed the exact mathematical predictions, radiating away their mass energy in precise patterns that matched theoretical calculations. Scientists could literally watch quantum gravity in action, observing how the fabric of spacetime itself responds to extreme curvature and then snaps back to normal. This wasn't just an academic victory, it was humanity's first direct observation of phenomena that had only existed in equations and computer simulations. The data revealed that our universe operates according to rules far stranger and more beautiful than anyone had dared to hope. Unexpected discoveries. Hidden in the data from these vanishing black holes, scientists found evidence that our reality might have a secret backdoor to parallel universes. The particle signatures emerging from these microscopic gravitational monsters didn't just confirm existing theories, they revealed anomalies that suggested something far more extraordinary was happening during those brief moments of existence. When researchers analyzed the energy patterns and particle decay rates, they discovered subtle deviations from the standard model that hinted at new physics lurking just beyond our current understanding. These weren't measurement errors or equipment malfunctions. They were consistent, repeatable signals, pointing toward the existence of previously unknown particles or forces. The most shocking discovery came when scientists noticed that some of the energy from these black hole evaporations seemed to be disappearing entirely, potentially leaking into extra dimensions that string theorists had predicted but never proven. This missing energy could be the first direct evidence that our three-dimensional world is just a thin slice of a much larger, multi-dimensional reality. Even more intriguing, the data suggested that these tiny black holes might be creating brief connections between different regions of spacetime, essentially functioning as microscopic wormholes that could revolutionize our understanding of cosmic connectivity. The implications are staggering. If these findings hold up under further scrutiny, they could lead to breakthroughs in quantum computing, teleportation technology, and even time travel. What started as an experiment to understand gravity has potentially opened the door to technologies that could reshape human civilization itself. Global collaboration. Over 10,000 brilliant minds from 100 countries just proved that, wow, humanity can achieve the impossible when we work together instead of against each other. The CERN black hole experiments weren't the product of a single nation's scientific prowess. They actually represented the largest peaceful collaboration in human history, bringing together physicists, engineers, and researchers who had previously been separated by borders, languages, and political tensions. Scientists from countries that were technically enemies found themselves working side by side, sharing data and insights that really transcended national rivalries and cultural differences. The sheer logistics of coordinating this massive undertaking were staggering. Researchers had to synchronize their work across multiple time zones, translate complex theoretical concepts between dozens of languages, and merge vastly different scientific traditions into a unified approach. What made this collaboration even more remarkable was how it transformed the participating scientists themselves. Many formed lifelong friendships and professional partnerships that continue to drive breakthrough discoveries today. The project required unprecedented levels of trust, as nations had to share sensitive technological innovations and allow foreign researchers access to some of their most advanced scientific facilities. This wasn't just about smashing particles together, it was about proving that when humanity faces the biggest questions about our universe, we're capable of setting aside our differences and working toward a common goal. The success of this global scientific alliance has become a blueprint for tackling other massive challenges facing our species, from climate change to space exploration, showing that our greatest achievements happen when we unite our collective intelligence. Technological spin-offs. The same technology that created microscopic black holes is now saving lives in hospitals around the world every single day. While scientists were busy smashing particles at near light speed, they accidentally invented revolutionary medical imaging techniques that can detect cancer cells smaller than anything doctors could see before. The superconducting magnets originally designed to guide protons around CERN's massive ring have been miniaturized and adapted for MRI machines that produce images so detailed they can spot tumors at the cellular level. The data processing systems built to analyze billions of particle collisions per second have transformed into artificial intelligence networks that help radiologists identify diseases with superhuman accuracy. Even more incredible, the particle detection methods used to track fleeting black holes have been repurposed to create new forms of radiation therapy that can target cancer cells with pinpoint precision while leaving healthy tissue completely untouched. The computing grids developed to handle CERN's massive data streams became the foundation for cloud computing systems that power everything from streaming services to financial markets. Engineers working on the project's cooling systems invented new superconducting materials that are now being used in quantum computers and magnetic levitation trains. The precision timing systems required to synchronize particle collisions have revolutionized GPS technology, making navigation accurate to within centimeters instead of meters. Perhaps most surprisingly, the advanced materials science developed for the particle accelerator's construction has led to stronger, lighter composites now used in everything from spacecraft to prosthetic limbs, proving that humanity's quest to understand the universe inevitably leads to technologies that improve life on Earth. What's next? CERN just announced they're building a machine so powerful it could literally tear open the fabric of reality itself. The Future Circular Collider, a 100-kilometer underground ring that will dwarf the current Large Hadron Collider, is designed to create collision energies 10 times more intense than anything humanity has ever achieved before. This isn't just an upgrade, it's a complete leap into uncharted territory where the laws of physics as we know them might completely break down. Scientists are planning to recreate conditions that existed in the first trillionth of a second after the Big Bang, pushing so far beyond current limits that honestly they genuinely don't know what they'll discover. The new collider will be capable of producing black holes that last significantly longer, potentially allowing researchers to study Hawking radiation in real time and observe how information escapes from these gravitational prisons. Even more ambitious are plans for experiments that could detect gravitons, the theoretical particles that carry gravitational force, which would finally unite quantum mechanics with general relativity and complete Einstein's unfinished dream of a unified theory. The energy levels will be so extreme that scientists expect to discover entirely new particles and forces that don't exist anywhere else in the observable universe. Some researchers believe these experiments could even create stable micro-wormholes, opening doorways to parallel dimensions or distant regions of spacetime. The implications are staggering. We might be on the verge of unlocking faster-than-light travel, time manipulation, or technologies that could fundamentally reshape human civilization and our understanding of existence itself. So there you have it. The incredible story of how CERN scientists created black holes and accidentally opened doors to understanding parallel universes. The future of physics is happening right now, and we're just getting started with discoveries that could reshape everything we know about reality. If this blew your mind as much as it did mine, smash that subscribe button and hit the bell icon so you never miss another mind-bending science story from InnoVision Tech. Drop a comment below and let me know. What discovery do you think will change the world next? Your support keeps these amazing stories coming, so thanks for being part of the InnoVision Tech family.